We have a triangle here, triangle ABC, and it has three sides. The lengths are A, B, and C. And we also have three angles, angle A, angle B, and angle C. The sine rule states that the ratio of length of any side to the sine of the opposite angle will be equal for all the sides. Let's see what that actually means. Let's say we'll take the side BC. The length of the side BC is A. What is the opposite angle of A? Angle A, right? So sine of that angle, that means sine of angle A. Then let's talk about that B. So we have another side, the length is B, and opposite of B is the angle B, so sine of B angle. And just like that, the length C and sine of the opposite angle C. The sine rule states that all three will be equal. Now it's a fantastic ratio. We can actually use this ratio to find a missing angle or a missing side. Now let's look at some maths and see how these angles and ratios can actually be used. Let's go. In our first math, we have been given a triangle ABC. We have been given the information of AC. The length is 4 centimeter and the angle just opposite to 4 centimeters, 45 degree. We have another side AB which is 5 centimeter, but we are not given the angle opposite to it, and we have been asked to find that angle ACB. That means we have to find angle C. Now what does the sine rule tells us? Let's take it as side B. We know that length of that side divide by sine of the opposite angle, which is this one. Let's take it sine B, equals this one AB. Let's take it as C, and the opposite angle is sine C, right? Okay, we know that this ratio will be equal. Now let's see what happens if you put the values. We have the value B, which is 4, and in place of angle we have 45 degree. We have C, which is 5 centimeter, and we do not have sine C or angle C. That's what we are asked to find. Now if you calculate it, you're gonna get 4 sine 45 is basically 0.707, and 5 divided by sine C. If you use a calculator, you're going to get a value here which is 5.66 equals 5 divided by sine C. Now as we want to calculate the angle C, we have to move it to the left side, so it will be multiplied. So 5.66 will be multiplied by sine C equals 5. Now we have to move that 5.66 to the right side. So sine C, it is multiplied here. If you take it to the right side, it's going to be divided, which gives us 5 divided by 5.66. Okay, now when you want to calculate the angle, you have to move the sine 2, then it goes to the right side, it becomes sine inverse 1. So you have C equals sine inverse 1, and if you calculate it 5 divided by 5.66, the value comes around 0.88. So put it in a calculator, you will get a value around 61.6 degree. So just like that, using the sine rule and the opposite angles and the sides, we easily calculated the missing angle. So now you want, in our example 2, let's see when the angle is given how we can calculate the opposite side. In our second example, we have another triangle, and in this triangle we have a side, and can you guess which one is the opposite angle of this side? It may be a little tilted, but at angle C is the opposite angle of this side, 3 centimeter. And then we have another angle which is 100, and we are asked to find AC, and from the figure we can clearly see that AC is the opposite angle of 100 degree. So be careful, sometimes the figure may be tilted a little bit, but you should still be confident that there will be the opposite angle, or you can just think that it's straight and then find out which angle will be the opposite angle. Now let's apply the sine rule again. So what do we know? We know length of any side 3 centimeter divided by sine of the opposite angle. The opposite angle here is, yes, 50 degree. It will be equal to the length of AC that we don't know, we are asked to find, and divide by sine of the opposite angle. Opposite angle is 100 degree. Now let's just calculate. So 3 sine 50 will give you a value of 0.766 equals AC, and if you do sine 100, then you will also get a value of around 0.98. So now if you calculate this one, you're going to get a value of 3.91, and this 0.9 is divided here, so if it comes to the left side it's going to be multiplied, so 0.98 equals AC, right? Let's just flip and write it straight. AC equals, when you calculate it, you're going to get 3.8 centimeter. So just like that, also when you have two angles but you are missing one of the sides, you can use the angle with the sine rule and calculate the length of the other side. So this is it for the sine rule. We can calculate both angles and sides using the sine rule. Now let's see how the cosine rule works and how we can apply it to calculate some maths. Now let's see what the cos rule tells us. Now we have a triangle PQR. We have the lengths of the sides A, B and C, and there is an angle given between A and B. The side A and B, the angle is given. We can use cos rule to find the length of the C where the angle is not related. Okay, we can use that thing. So the cos rule basically says that cos of the angle given equals to the sides square with the angle. You know, A and B, both of them are with the angle, so they will be squared and added, and minus is the side square of opposite of the angle. That means C square opposite of the angle, divide by 2AB. Let's understand again. We will have A square plus B square, side square, and minus the side that is opposite to the angle, square of the side that is opposite to the angle. Okay, divide by 2AB. Now there might be two questions, which one I take as A and which one is B. So A and B actually doesn't matter. Whatever the angle you have, the two sides with that angle is A and B. You can even put this one as B and this one as A, it doesn't matter. But the second question is important. Which one is C? C is always the opposite side of the angle. Whatever angle you are taking here, whatever the side is opposite to that angle is C. Here theta is our angle, so opposite to theta is the side C. So we are taking it as C. If the angle was here, we would have called A as minus A square. Okay. If the angle was here, we would have put minus B square, like that. Let me show you how we would have done that. Let's say the theta is not here. Let's say the theta is here. Now, if we write the cos rule, it would be like cos theta equals, you see, A and C, these two sides are with the theta. So we will write A square plus C square. And who's opposite to the theta? B, right? So we're going to write minus B square and divide 2 the sides given, A and C. Understood? I guess it is clear now which one is A, which one is B, and which one is C. Now let's see how we can use this formula to solve some maths. So in our first example, we have been given a triangle. We have two sides, the angle between it and the opposite side. We have been asked to find the angle theta. Now, as I said, we have three sides. We have been asked to find an angle, so we can use the cos rule. What was the cos rule? So cos rule is cos theta equals the sides with the theta or with the angle. What are the sides? 8 and 5.5. Which one is A, which one is B? Does not matter. Let's take A, 8 as the A. So 8 square plus 5.5 square, and C is always opposite of the angle. So which one is opposite of the angle? 5 centimeters opposite of the angle. Now that will be negative square. So divide 2 multiplied by A multiplied by B, which is 5.5. When you calculate it, we are not doing anything with the cos theta yet, so it stays there. 8 square is 64, 5.5 square is 30.25, and then minus 25. If you just calculate the bottom one, you're going to get 88. So it's a simple calculation from now on. So cos theta equals, you have 94.25 minus 25, so 69.25 divided by 88. So when you divide, you get a result of cos theta equals 0.78. So we know that when you need to find theta, we have to move the function in there. So cos inverse 1, 0.78, which in turn will give you a result of theta equals 38.7 degree. So just like that, when you have three sides given and you are asked to find angle between any of the two sides, you can use the cos rule and find the angle. Now let's see when the angle is given and the opposite side is not given, how we can use the cos rule to find the opposite side? Let's move on to our example 2. So in our second example, we have been given a triangle ABC and we have two sides and the angle in between them. Remember, it's not opposite of any side. If it was opposite of any side, we could have used the sine rule. But the angle in between them, and we have been asked to find the opposite side of this angle. So we can use the cos rule. So let's see how we can use the cos rule here. So cos 65, as we know, cos of any angle equals to the sides with the angle, that means 7 and 9. Again, it does not matter which one you are taking at A and B, it doesn't matter. So 7 square plus 9 square minus the opposite side of the angle, which is AC. We don't know, we have been asked to find it. So AC square, divide 2 multiplied by 7 multiplied by 9. So when you find cos 65 in your calculator, you're going to get a value of 0.42, and here you get 49 and 81 minus AC square, divide, if you multiply, they're going to get 126. So 126 is divided, when it comes to the left side, it's going to be multiplied to 0.42 multiplied by 126. If you add them, you're going to get 130. So minus AC square. So multiplying this, you're going to get a result of 52.92. This thing is going to come to the left side, so you're going to get minus 130 equals minus AC square. So when you subtract it, you're going to get 77.08. Obviously negative because it's the bigger one. So minus AC square. You can just remove negative from the both sides, as both of our sides have negative. And when you make it stating on the right, AC square equals to 77.08. So what we can do at this stage is to remove the square with the root over. So whenever you root over AC squared, you get AC square is removed. And when you root over 77.08, you're going to get a value of 8.76 kind of value. Okay. So just like that, when you are given two sides and the angle in between them, and you are asked to find the opposite side, you can use the cos rule and calculate the other side. So this is it for cos rule. Now let's see how we can use the trigonometric functions to find the area of a triangle. You already know that we can calculate the area of a triangle using half into base into height, right? But when there is a triangle but we don't have the height, but we have the angle given between two sides, we can still calculate the area of that triangle using trigonometry. For that one, we're going to use a formula. For this triangle ABC, if you want to find the triangle area of ABC, we can use a formula: half multiplied by A multiplied by B and then multiplied by sine theta. Again, the theta must be between the two sides that you are using here. If you use that formula, you can easily find the area of this triangle. We are going to solve one math and see how we actually can do that. As you can see, we have a triangle PQR. We have been given two sides, 6 centimeter and 5 centimeter, and the angle in between those sides. Now we have been asked to find the area of this triangle. Obviously, we cannot use half into base into height. We don't have the height of this triangle. But we learned we can use another formula. The formula is, if we want to find triangle PQR's area, we can use half into AB and sine theta, right? A is 6, B is 5. Just like the previous one, which one is A, which one is B, it doesn't even matter. So, and we have sine 30 degree. If we use it, we can get half multiplied by 30, and the value of sine 30 is 0.5. So when you calculate it, you're going to get 7.5, and it's an area, so the unit will be centimeter squared. Just like that, even when you don't have height but you have the angle between two sides, you can calculate the area of a triangle. So that's all for trigonometry. We have solved right angle triangles and also non-right angle triangles. We have seen the Pythagoras theorem, also trigonometric functions, and the sine rule, cosine rule, and how to calculate the area. So if you have seen both the videos, I think you should not have any doubt on trigonometry anymore. In another video, we're going to solve some exam questions to see how we can actually answer questions in our exam using whatever we have learned so far. Stay tuned, and we'll have a lot more videos coming. Our next video will be on differentiation. I'm sure that it's going to help you a lot. Subscribe the channel and stay with me. See you in our next video.